We are told, find the values of the constants a and b such that the limit as x approaches 0 of the cube root of ax plus b minus 2 all over x is equal to 5 over 12. Alright, we know that we have to find two constants, and they're in this limit expression. Well, whenever I have a limit question, I always like to plug in what x approaches into the expression so I can try to deduce what happens, what to do after that. So you can see that I've copied down our limit expression here. So it is the limit as x approaches 0 of the cube root of ax plus b minus 2 all over x. So let's plug in x equals 0 for our fraction here. So if I write it out, a times 0 for x, well, that's just 0. So under this cube root, we only have b. So in our numerator, we'll have the cube root of b, and nothing happens to this minus 2, so we have minus 2. And our denominator is x equals 0, so it's just 0. Alright, now what do we do from here? Well, one thing we know, and this is one of the key realizations, is that this limit exists and it is a finite number. So what does this mean? Well, when a limit exists and it's a finite number, it's usually in indeterminate form. So what is indeterminate form? Well, indeterminate form is simply 0 over 0. Why does it have to be an indeterminate form? Well, if we had a constant over 0, which is also undefined, that probably isn't a limit that exists, because if we graphed this expression right here, made it equal to y, at x equals 0, this function would probably approach an asymptote. And we don't want that, because we know that this limit, because if this was an asymptote, the limit would be infinity or negative infinity or wouldn't exist. We know that this limit is a finite number. So we know that when we plug in what x is equal to, we have to get indeterminate form, which is 0 over 0. Well, we know our denominator is already 0, so our numerator must also be 0. So if we know our numerator is 0 and we just have b here, we can find b. So we can say that the cube root of b minus 2 is equal to 0 to solve for b. If we add 2 to both sides, we get that the cube root of b is equal to 2. And we just cube both sides. The cube root of b cubed is b, and 2 cubed is 8. Alright, now, we already have one of our constants. We know that b is equal to 8, and it has to be equal to 8 because our numerator here must be 0, because our denominator is 0. And this limit is finite. Alright, now we have to tackle finding this a. Alright, so let's start by bringing down our limit expression. Alright, so what happens if we plug in x equals 0 again? You can see that I've put in b equals 8 right here. Well, if x equals 0, we just get 0 for this term. We get the cube root of 8, which is 2, minus 2, and we get 0 in the denominator. If we just get 0 over 0 again, that doesn't really help us. We can't find a that way. But what we can do is try to put this into another form, and then plug in x equals 0. See where that takes us. So one way to do that is we can remember our good friend L'Hopital. And L'Hopital had a rule, and I will tell you what his rule tells us. So L'Hopital's rule says that the limit as x approaches some, let me make that a little neater, x approaches some number, and your limit expression is a fraction with f of x in the numerator and g of x in the denominator. F of x and g of x are just some expressions that contain x. we know that if f of c, because this is some arbitrary constant, right? This can be any constant, it doesn't have to be x approaches 0. F of c over g of c is equal to 0 over 0, or infinity over infinity, which is also indeterminate form, by the way. We know that this limit is also equal to the limit as x approaches x approaches c of the derivative of f of x over the derivative of g of x, f prime of x and g prime of x. So let's see how we can apply that here. Well, we already know that if we plug in x equals 0, we get 2 minus 2 in the numerator, right? And we get 0 in the denominator. So this rule checks out. So we'll have to take the derivative of our numerator and the derivative of our denominator. Well, let's start with our denominator. The derivative of our denominator is just 1, right? Because it's just x, 1x. You can also think about how that works with the power rule. The trickier part is our numerator. So let's take this numerator part by part. Well, we have this -2 out here. We know that since this is a sum of two things, we can just take the derivative of each part. So if we take the derivative of this -2, d over dx of any constant, -2 is indeed a constant, is just equal to 0. So we do not have to worry about the derivative of -2. We know that it's 0. So we can say that this limit is equal to the limit of the derivative of this part as x approaches 0. D over, and again, that's because derivative of 1x is just 1. Derivative of -2 is 0. This thing plus 0 divided by 1 is just the derivative of this thing. So, and let's bring this cube root to an exponent out here. So a cube root is the same thing as taking something to the power of 1/3. Now is the tricky part. We have to think about chain rule. So what was chain rule? Well, chain rule tells us that if we are taking the derivative of a composite function, which is just f of g of x, well, that is just equal to f prime of g of x multiplied by g prime of x. So the derivative of f with respect to g and times the derivative of g. So let's see how that works for our ax plus 8 to the power of 1/3. Well, what's our outer function? Well, I think our outer function is x to the 1/3, because we can take the derivative of that. So that means our inner function is ax plus 8. So let's do that. Let's say our outer function, right, f of x is equal to x to the 1/3. So what we can do, we can take f prime of x and just plug in g of x wherever we see x. So f prime of x, if we use our power rule, is equal to 1/3 times x to the 1/3 minus 1. What is 1/3 minus 1? Well, that's just 1/3 minus 3 over 3, which is -2/3. So times x to the -2/3. I think it would be a lot easier to use this if we put this into a fraction. So as a fraction, this x to the 2/3 goes to the denominator because that is negative out here. So we just have 1 in the numerator. We still have this 3 in the denominator, and that is multiplied by x to the 2/3. So we know that f prime of g of x, we can just plug in g of x wherever we see x. Well, what's our g of x? Well, our g of x is what's inside this x to the 1/3, which is ax plus 8. So g of x is equal to ax plus 8. So if we just plug in ax plus 8 here, if we just plug in this ax plus 8 here, we get 1 over 3 times ax plus 8 to the power of 2/3. All right, we still have to multiply by this g of x, so we have to take the derivative of this. What is the derivative of ax plus 8? Well, the derivative of 8 is just 0. The derivative of ax, since a is a constant, is just a. So g prime of x is equal to a. If you want, you can also think about that with the power rule. But just know that if a line like this, ax plus 8, that is the equation of a line, it'll always have a slope of a. So g prime is equal to a. So what is our derivative of our numerator? Well, we just multiply these two things, right? F prime of g of x times g prime of x. So it is the limit as x approaches 0 of, let me put this in blue, we can put a in the numerator because 1 times a is just a. And in our denominator, we have 3 times ax plus 8 to the power of 2/3. All right, we are getting somewhere. Now, we have an a by itself, so we can find a way to figure out what it is. So let's do what we did before. Let's plug in x equals 0. This term will become 0, but that's okay because we have this a up here, so we can figure out what a is. So plug in x equals 0. So if we do that, in our numerator, the a will stay because there's no x attached to it this time. We will have a, and in our denominator, we have ax. So a times 0 is just 0. So in this brackets here, we'll just have 8. 8 to the 2/3. And what is this equal to? Let's just evaluate this denominator. So this is equal to a to the 3 times, well, taking something to the 2/3 power is to take the cube root and then to square it. So let's see. This is equal to a times 3. The cube root of a is just 2. If we take that, we'll have 2 in our brackets, and then if we square the 2, we get 4. So 8 to the 2/3 power is 4. Cube root is 2, square the 2, we get 4. So what do we get? We get a over 12. Over 12. Now this is interesting. It's interesting because now, since our denominator is not 0, this is an actual number. This is defined. So we know that our limit has to be equal to a over 12. So our limit is a over 12. What other information did they give us in the question? Well, we know that our limit is also equal to 5 over 12. So what equation can we make from this? We can say that, oh, wrong shade of green. We can say that a over 12 is equal to 5 over 12, right? We use L'Hopital's rule to get this expression, and we know that our limit has to be equal to a over 12. And based on what they gave us, they literally told us the limit has to be equal to 5 over 12. So that's how we came up with this expression. So how do we find a? Well, I'm sure you can see it. We can multiply both sides by 12. That gets rid of the 12. And a is equal to 5. So if we do a little conclusion statement, we know that b is equal to 8 and a is equal to 5.